Mr. Beak's math class. Mr. Beak's math class. Yeah! Woo!
All right, thanks for joining me, Mr. Beak, for another wonderful lesson on learning. Today we're talking about 2.1, which is inequalities. Hint where there is equal. Other hint word in there is in. That means not equal. Okay? So what we're talking about with inequalities is these greater than, less than, greater than or equal to, less than or equal to, that type stuff. Okay? So just as a little intro. Now, hopefully today on the learning skills, we're always trying to be at a 3 or a 4, meaning like, hey, you're doing a pretty darn good job on this stuff. You understand it all and aren't making many mistakes. You could maybe teach it to other people. If you are in the 1 to 2 range, just let me know and we can get you some more help. Okay? So, first off, you don't have to write this down on a sheet of paper, but write down 3 different heights of people that can ride this thing. You ever been to an amusement park? Valley Fair or something, and they got those little poles. Hey, you got to be taller than this to ride on this ride. Well, 54 inches is however tall you have to be to ride on this ride, the Talon. I wonder what it is. Sounds exciting. All right, so if you have to be 54 or more, it means you could be at 55 inches tall and you would be able to ride on it. You could be at 63 inches tall and be able to ride on it. You could be 117 inches tall. You'd be pretty darn tall, but you'd be able to ride on that ride, right? So that's kind of, there's lots of answers for these. There's not just, hey, x equals 54. Well, if you're 54, you could ride on that, but you could be more, right? So there's lots of answers. That's why we have inequalities. How about this one? On an elevator, more than 8 people at a time will cause this elevator to stick. First off, that's not very mathematical because there has to be a limit, right? 2,000 people or something, but I guess 8 people, they could be all children that weigh 20 pounds, but more than 8 people can't ride on that, all right? So when will it get stuck? It'll get stuck with 9 people, and 10 people, and 15 people. If you cram them all in that elevator, I guess it's going to get stuck. So those would be some options, all right? So how about we're driving down the road. This looks like a sweet, beautiful drive with those bluffs and the green hills. The speed limit is 40 miles per hour. That means that's the limit. That means you can go 40 but not go over it. So 4 speeds, they'll give you a speeding ticket. Well, if you were going 41, technically you are speeding. You probably won't get pulled over for that, but you're breaking the law. All right? How about 60 miles an hour? How about 100 miles an hour, right? You're going way too fast. I guess we need one more. How about 153 miles per hour? Dangerous, especially on that 40 mile per hour speed limit. Okay? So how would we write an inequality for this? We don't want to have one answer that can contain all the possible speed limits for giving you a ticket. Okay? And so we'll just generically say X. Maybe if you want to write S for speeding, but my S's look like 5s if I'm writing them. And I want to have all the numbers that are more than 40. So it's going to be all the numbers that are greater than 40 are going to give you a speeding ticket. Now, the question is, do I put that or equal to, right? If you went 40, would you get a speeding ticket? No. So it's not equal to 40. That was a big eraser there. It's just all the numbers that are over 40. So technically, if you went 40.1 miles an hour, you're getting a speeding ticket, right? Or you're at least breaking the law. Okay? So that is the answer to what our inequality looks like. And now if we want to graph it, okay? Um, here's how I'd graph this. All the time, we just want our one important number, in this case it's 40, right in the center. And we're going to shade all the ones that are higher than 40, okay? Well, if this is just a number line, here's 41, here's 42, below is 39, right? And so I'm going to have all the numbers that are more than 40, right, get a speeding ticket. So that's how I'm going to shade it. I'm going to shade it just kind of like that if you want to really shaded in or whatever. But there's got to be some sort of circle at 40. And what it's going to be like is all the less than or greater than and all the less than or equal to greater than or equal to's, they have a certain style of dot. Okay? These ones are going to be an open dot that shade a certain way. These ones are going to be a filled in dot that shade a certain way, depending on the numbers for each one. Okay? So this one is kind of looks like one of those. So we're going to have an open dot right at 40 because you could go 40 and you'd be fine. But 40.1, you'd have a speeding ticket, potentially on your hands, all right? So anyways, here's what we're doing. Writing and graphing inequalities in this section. This is just a quick intro lesson, but if you want to kind of take this little chart and study it and memorize it and stuff, print it off for notes, whatever, you can use that because this is going to be kind of the 4 major signs for this entire chapter, and we're going to just be expanding and doing more stuff with that. Okay? So we're going to just do a couple random fun examples, and then I'll graph it just so you can kind of see a bunch of examples and get this system down. Okay? Number 1 says the daily limit for hunting wood ducks is 3. I just made this question up. I don't really know if that's true, but let's go with it. Write an inequality, so the second says inequality. You should be thinking less than, greater than, equal to, all that stuff, okay? If you obeyed the speed limit, or the duck limit, all right? So first off, I'm going to just say D for ducks. I'm going to say my one important number there is 3, and we just have to decide which one of those 4 signs we get, okay? If we obeyed the limit, that means I could have, the limit is 3. I could have, if I got 0 ducks, I'd be fine. 1 duck, 2 ducks. Even if I got 3 ducks, I'd be all right, okay? Well, all these numbers here, if we technically kind of move those over, because those are the good ones, right? Are these numbers bigger than or less than 3? Well, those numbers are all less than 3, and they all get 3 is included in there, okay? I like to think of the sign as like alligator mouth, okay? And it's going to eat the most amount of food possible, right? So for a little example here, if I had 5 pieces of cake or 2 pieces of cake, well, I'd rather eat the 5, so I'm going to open towards that 5 because that's a little bit bigger, okay? So there we go on that one. Let's go down to number 2. In Minnesota, let's skip down to number 3. I feel like it. We're just going to jump around. To pass your driver's test, maybe you guys have taken driver's ed, maybe that's coming up, but you need to score at least 70. Let P represent the number of points. So I'm going to just write down P. I'm going to write down 70. That's my important ones, okay? So what I like to do is over on the left-hand side, my variables, I like to write different numbers that satisfy that equation. So if at least 70, just to get in my head which way this is going to open up and if I have to include it, okay? So example 1, hey, if I ace that test, if I got 100%, would I pass it? Yes, right? If I got 80, would I pass it? Yes. If I got 71, would I pass that? Yes. Here's the question. If I got 70, would I pass that test? The answer is yes, because I just need at least 70. So if I got 70 or more, and so since this number is included there, that's the number there that we want, it means that we're gonna have the or equal to, right? And all these numbers are
That's a
bigger
good point.
than the 70 there, right? 100 is bigger than 70, so it's gonna be P is greater than or equal to 70. All right? Let's try just a couple more. I'm gonna do number 4, and then we'll call it a day after that. I wonder if I can just scroll these down so they're out of the way. Let's do that. And then let's hide it. All right. Children under 12. It's all about the words. Children under 12. Get a discount price at the movie theater. That'd be cool if I was a under 12-year-old. Unfortunately, I'm a little too old for that discount. All right. Write in inequality for the ages that get a discount. I'll just write C for children. I'll write 12. Always, we're going to just write down the exact number that we want. Okay? Now, like I said, I like to put the numbers on this side that satisfy that equation. Who gets the discount? A 2-year-old would get the discount. My 1-year-old little son, he would get a discount. My 3-year-old little daughter at home, she would get the discount too. They're so precious and I love them so much. And they're saving me money at the movie theaters, all right? Now, would a 12-year-old get the discount? The answer is no, they wouldn't. An under 12-year-old, okay? So all these numbers right here, 1 and 3 are less than 12, right? And since we are not since we are not including that 12, it means I don't include the line underneath. It's just going to be children that are less than 12, okay? Those are the people that get the discount to the movie. Their parents are happy, okay? When you turn 12, you're full price. Anyways, hopefully that's making sense to you guys. Take care.
Mr. Big's math class. Mr. Big's math class.